Welcome to this episode of Easy Physics, where we delve into the fascinating world of science and unravel the secrets behind popular culture icons. Today, we will explore the physics behind Iron Man, the iconic superhero from the Marvel Universe. Iron Man, also known as Tony Stark, is a genius inventor who dons a high-tech suit that grants him incredible powers and abilities. While the suit itself is a work of fiction, we can still examine the scientific principles that make Iron Man's feats seem plausible. The most significant aspect of Iron Man's suit is its ability to achieve powered flight. Flight is governed by the principles of aerodynamics and propulsion. In order to stay airborne, an object must generate enough lift to counteract the force of gravity. The suit achieves this through the use of repulsor technology, which allows Iron Man to manipulate magnetic fields to generate lift. By creating a repulsive force between the suit and the Earth's magnetic field, Iron Man can defy gravity and soar through the skies. Propulsion is another key element of Iron Man's flight. The suit utilizes jet engines to propel itself forward. These engines are strategically placed in various parts of the suit, allowing for controlled movement and maneuverability. By expelling high-speed jets of gas, Iron Man can generate the necessary thrust to overcome air resistance and achieve impressive speeds during flight. To control his movements while airborne, Iron Man employs a system of stabilizers and gyroscopes. These components help maintain stability and balance, allowing him to make precise adjustments in midair. By adjusting the distribution of the suit's weight and manipulating its center of gravity, Iron Man can execute complex maneuvers with ease. Another remarkable feature of Iron Man's suit is its protective capabilities. The suit is constructed using advanced materials such as titanium alloy, carbon nanotubes, and artificial muscles. These materials provide durability and flexibility while also enhancing Iron Man's strength. Additionally, the suit incorporates a heads-up display, HUD, and sensors that provide real-time data and analysis, enabling Iron Man to react quickly and make informed decisions. One of the most iconic features of Iron Man's suit is the energy source that powers it, the arc reactor. This miniature, self-sustaining nuclear power plant provides the necessary energy to operate the suit's various systems. While the concept of a self-sustaining power source is still a topic of ongoing research in the real world, the idea of harnessing clean and renewable energy is an important area of scientific exploration. In order to enhance his offensive capabilities, Iron Man's suit incorporates a wide range of weapons, such as repulsor beams, missiles, and lasers. These weapons rely on the principles of electromagnetism and energy conversion. Electromagnetic fields are used to generate and control energy, allowing Iron Man to project powerful repulsor beams or launch missiles with precision. In conclusion, while the physics behind Iron Man's suit may seem far-fetched, many of its features can be understood in the context of existing scientific principles. Flight is achieved through the manipulation of repulsive forces and propulsion systems, while stability and balance are maintained using stabilizers and gyroscopes. The suit's protective capabilities are based on advanced materials, and its power source draws inspiration from ongoing research into clean energy. Iron Man's offensive weapons rely on the principles of electromagnetism. Although the suit itself may be fiction, exploring the physics behind it allows us to appreciate the scientific concepts that make Iron Man's adventures seem thrilling and believable.